Okay, hello everybody. If you just need a little additional review or if we went too quickly through the review, whatever, this is available for you. All right, we started out talking in our review about the logical fallacies, which is living in the media age, the section from the textbook. And as I said in class, you have all these definitions. What we need to do with them is you need to be able to write a definition that makes sense to you and take ownership of that. So what I have recommended that you do on this is that you complete the definitions in your own words to show that you understand it and be able to create an example for each. So like, let's pick one. A false cause. I wore a UT jersey while watching the football game and they won, so me wearing the jersey is what made them win. So that would be an example of that, and have an example in your mind so that you can relate it to another one that you come across. And we'll go over some of these when we do the actual review problems. Okay. So the next thing we talked about was sets and Venn diagrams. And in the sets and Venn diagrams, oh my goodness, I'm not as organized as I should be. There are some general things that you need to know. When you have a Venn diagram, you are going to have a rectangle which represents the universe. And that is going to be the total of whatever it is polled. Okay. Then inside you're going to have it split up into different regions. So I'm going to cleverly call this set A and this set B. And I'm going to do what I normally do and just choose this as region 1, region 2, region 3, and region 4. Okay. If you have 3 circles, it's going to split it up into 8 regions. So anyway, let's see how we can relate this to our two-way table. So either your rows are going to represent one of the circles, and your columns are going to represent the other circle. So to be consistent with what we did in class, I'm going to let this be A and this be B. So A, you're either A or you're not A. So you're a student or you're not a student, depending upon what your universe is and what they're trying to get information about. You drive a truck or you drive a car. All right, and then the same thing with B. You're going to be either part of B or you're not going to be part of B. Each of these 4 squares will represent one of the 4 regions. This represents that you're both A and B. In our Venn diagram, if you're inside the A circle and inside the B circle, that's going to be this region right here. So this is your R2. If you're in A but not in B, that means you have to cut this part out. So this is your region R1. So R1 is this part outside. That's inside A but outside of B. This space here represents B but not A. So that's going to be region 3. Region 3 is inside B but not inside A. So that means, if we use our truck, if you drive a truck but you do not drive a car. So that's going to be our R3. And then outside of this, is everything in the universe that is outside of both of the circles. So this is going to be your R4. It is not part of A and it is not part of B. So there's your R4. And then your universe is the total of all of them. The total of all of these. So that's going to be this region here, which is your universe. And that's the total of all the regions. Okay. Then this number here is going to be the total in A. It's going to be the total of R1 plus R2. Not A is the total of everything outside of these regions, or in these regions. So it is the total of R3 plus R4. B is everything inside the B circle, so that's going to be R2 plus R3. And not B is everything outside of the B circle, so it's going to be R1 plus R4. And you'll notice here that if you add these up, you have R1 plus R2 plus R3 plus R4, so it's the total of all of the regions. Same thing here. Okay. If you look at, there are two different statements that we're using. We're using and or. And we need to know that this is the inclusive or. If you have an and statement, that is the overlap. So if this is region A and this is region B, the and is A and B, which is just the overlap. Now the inclusive or, this is the inclusive or. And if this is A and this is B, it is A or B or both. So that means you are inside either circle. Okay. And remember the example that Joseph gave in class about the prizes. Okay. If you get a prize for A or you get a prize for B, that means you can get a prize for both. Okay, then there were three different definitions that we needed to know about how sets interact. The first one are overlapping sets. So these are items where you can belong to one, you can belong to the other, or you can belong to both. And boy, my circles are awful. So if you're asking about whether or not you work, whether or not you're a student, you can be a student, you can work, you can be both, or you can be neither. Disjoint sets are sets that do not overlap. Okay, and if we look at this, if we go back to an example that we did about animals, if this is mammals and this is birds, there is no animal that is both a mammal and a bird. And then if you have a subset situation, that means one circle is completely inside the other. So if this were called A and this were B, the statement would be, if you are A, then B. If A, then B. So, and I think the example I used in class is if you are sour cream, then you are a dairy product. But it doesn't go the other way around. All right, and we did an awful lot of these where we went from a table to here, from here to a table. We had to identify sets, whether they were overlapping, disjoint, or a subset. We had to count how many were in the AND group, the OR group, or in each individual region. Okay. All right, then we went to 2A, which was all about unit conversion. And this was taking things and giving an equivalence, but in different units. If I want to, if I start out in kilometers and I want to end up in miles, what is the equivalence there? Or if I have gallons and I want to know how many pints that is, then I can do the conversion that is an equivalent expression. So, a conversion factor is just a unit fraction. And a unit fraction is anything that is equal to 1. So the examples I used in class, if you have 1 hour and 60 minutes, those are the same thing. So if you do that ratio, it equals 1. Or if you're dealing with money, if you have $1 and you have 0.8191 Great Britain pounds, that is also equal to 1 because these are equivalents. Now it's important to be able to do this and make sure if you have something that is equal that you can put them in a fraction and you can flip it upside down. Okay. So to convert units, here's what you're going to do. You're going to figure out what you're starting with. And you're always going to start with a fraction. And you're going to have some kind of units here. You may or may not have units in the denominator. Okay. And then you have to figure out, well, what do they want to know? So you are going to end with some other units. So if I wanted to go from dollars to pounds, I would start out with dollars and I would end up with pounds. Or if I would start out with gallons and end up with pints. And then all this space in the middle is using the conversion factors to change the units. Okay. You may be able to do it in 1, you may have to do it in 2. It just depends on the situation. Okay. So you are going to start by doing a conversion with some units over units, where these are the same and they cancel out. And again, you may have to do it again. Some units over some kind of units here, where this cancels out, until you get to the units that you want to end with. Okay, so let's just talk about the process checklist, and this is not something that you're gonna, but you want to think about this as you're doing these problems. You're going to start with the given value as a fraction. Okay. Then you are going, and I always write down my start and my end at the very beginning, and then I say, okay, well, what am I going to have to do in here in the middle to get from here to here? Then you are going to cancel the units using unit fractions, excuse me, until, whoops, you get the requested units. And again, it may be once, it may be twice. And then you want to simplify your results. Mathematically, you're going to do that on your calculator. And you are going to make sure you include the units, because that's kind of the whole point of it, is where we want to make sure we're to there. And you want to check your rounding. Okay, so now we are going to talk about square and cubic conversions. So let's say you have square units. For example, if you have inches squared, that actually means inches times inches. So if you're going to another unit, you're going to have to get rid of the inches twice. So you must convert twice. If you're dealing with cubic, for example, cubic meters, that really means meters times meters times meters. So you must convert three times. Okay, and lastly, we talked about currency conversion, which is just unit fractions. Okay, so this again is just a unit fraction. For example, the one we did up here, $1 is the equivalent of 0.8191 Great British pounds. And again, you can do that upside down as well. Okay, I'm going to stop this video here and we'll continue on with the practice problems in the next video.